All right, good afternoon, everyone. My name is Sean. This is Natalie. We're fourth-year civil engineering students, and our design city is Dar es Salaam. So a brief overview of our city. Dar is the largest city in Tanzania, East Africa. Its close proximity to the equator gives it a hot and humid climate and abundant solar gains. Tanzania is also one of the world's poorest countries, characterized by high levels of poverty, lack of access to electricity, clean water, and sanitation services. So its population in 2016 is estimated to be about 4.7 million. Considered the third fastest growing city in Africa, and it is projected to have a population of 16 million by 2050, which is a 241% increase in 34 years. So before I get to our infrastructure design, I will highlight some of the key figures from our 2016 urban metabolism diagram. The total GHG emissions in 2016 amounted to 2.9 megatons, which is equivalent of 629 kilograms of CO2 equivalent per capita, which is relatively low compared to developed cities, not because Dar is an exceptional green city, but it's more attributed to their lack of access to resources. Ground transportation makes up for the largest percentage of the greenhouse gas emissions due to their inadequate public transportation systems and old vehicles. Coming in second is the waste sector at 32% due to the poor sewage treatment and solid waste management by uncoordinated councils. It is also important to note that approximately 40% of solid waste generated in Dar is collected and managed. So these issues led to the development of our vision statement: to provide better health and safety standards to its citizens, to create synergies between environmental and economic sustainability for the city through implementation of more renewable energy resources, integrated multimodal transportation network, green building designs, clean water supply, as well as improved waste and wastewater management systems. Our source of inspiration comes from a publication by the OECD titled Green Growth and Developing Cities, which elaborates on the importance of developing that country and in a sustainable manner immediately, as opposed to focusing on conventional economic growth. So how do we apply this vision statement to Dar? I'll begin by talking about our strategies to conserve electricity and water usage in buildings. So as previously mentioned, Dar is in the cooling-dominated climate, so most of our efforts are on reducing the cooling demand of electricity. Here's my quick sketch of the PSPF towers in Dar es Salaam, the second tallest buildings in Dar at 36 stories, retrofitted with solar panels on the roofs and parts of the walls. So the first strategy to talk about are green roofs. Besides their benefit of improving air quality, green roofs can lower the surrounding area's temperature, reducing the area's cooling demand. The second strategy is active solar in the installation of solar panels on high-rise buildings, and passive solar in the reduction of window area of buildings and the placement of higher buildings on the north side of the city center to help shield the lower surrounding buildings from the sunlight. From a building the size of the PSPF towers as shown earlier, if the entire roof and parts of the north-facing wall were installed with solar panels, the annual energy generated can be around 1.6 terajoules per year. Since solar panels require a large portion of the roof area, we recommend the solar panels be installed on high rises and green roofs be focused on mid to low rises. The third strategy we recommend is gray water recycling for the use of toilet flushing. Something like the picture shown here. By looking at the average amount of water used for washing hands, brushing teeth, washing the face, etc., estimated reduction in water demand is 30 liters per capita per day. Now Natalie will talk about transportation and how it ties into land use and neighborhood planning.
Thanks, Sean. So in 2016, there are over 5 million of trip generation in Dar es Salaam. So with 60% being transit trips, 15% being automobile trips, and the rest is non-motorized trips. And among the 15% of the drivers, 75% actually indicated that they choose to drive because there's inadequate public transit system. So meaning that there's a huge potential of shifting drivers from driving automobiles to taking the transit through our design. So the first transportation element would be the BRT system. There's actually a current proposed BRT system in Dar, and so this proposed system is designed to meet the demand in 2030. So we propose that there would be an expansion in the system as well as additional bus routes that we proposed in our report. And also some other specifications such as the bus capacities and frequencies that we defined. And other than BRT, we decided that there will be a need for LRT systems. On top of the current existing commuter rail system, we'll add 4 additional routes for their LRT, and the stations of these LRT will be placed according to our planned future land use. And the third is the local bus system. So the existing bus system, which is called Dala Dala, will be completely phased out by the year of 2060 and replaced by a new official bus system. As you can see in this picture, this is a Dala Dala bus in Dar currently, and you can see that they have very small capacity and they're often in poor condition, which cause a lot of traffic and congestion and pollution problems. So some of the design guidelines we created for a local bus system are, for example, 20%, no more than 20% of the local bus can be run parallel to the BRT corridors. And the next component will be active transportation. So aside from the basic pedestrian and cycling facilities such as sidewalks and bike lanes, we also decided that we would provide a lot of supporting facilities to encourage people to walk and cycle more. So for example, every 5 kilometers we decided that we're going to install a sheltered rest stop with benches, and every 2.5 kilometers we'll install benches without shelters. So lastly, there will be a mobility hub to be created in the downtown core area, which is at the Central Railway Station currently. For this mobility hub, it will become a major trip generation spot for origin, destination, and transfer points that connect the LRT, BRT, and local bus system. And apart from just infrastructure, we also decided that there will be a fuel efficiency regulation for DAR because currently majority of the vehicles in the city are very old and they create a lot of pollution problems. So this will directly reduce the emissions from road transportation. So moving forward for land use, with a total land area of 1,400 square kilometers, there will be a very high population density in 2050 of over 11,000 capita per square kilometers. So our future land use planning will be focusing on developing more residential areas and commercial areas. And the neighborhoods that we are planning on majorly focused on is the neighborhoods around the LRT and BRT stations. And there will be the highest density areas will be in the downtown core area, which is the mobility hub that I just talked about. So city skyline will be similar to the concept that we talked about in class, which is the 2 transit lines plus foot, with the tallest buildings to be positioned in the north side of the hub, which is planned according to the buildings design that we mentioned earlier. But the exception to this will be along the coastline, which will have a low to medium density development because we don't want to disrupt the current land use in those areas, which is the tourism activities such as beach resorts and water parks. And we want to allow more sightlines as well. And for street patterns, they will mainly follow the existing patterns. I don't think you can see it over here, but then it's curvy and windy roads with a secondary road system inside, which is gridded. And there will be mainly 3 types of neighborhoods with a complete street strategy to be adopted, which is to allow safe, convenient, and comfortable travel and access to different modes of transportation. So here are the sketches for the first type of neighborhood, which is around the major LRT stations. As you can see here, there are going to be mainly very high dense, and also we focus a lot on providing green spaces and streetscapes. As you can see, there's actually a green space in front of the LRT stations with trees around it. And then we also strategically going to be placing the local bus system to connect to these LRT stations for connectivity. A second type of neighborhoods would be the major BRT stations, which will have a lower density compared to the LRT stations. And we will also have streetscapes and green spaces. That's actually a park on the left side over there. And local bus stations will be covering the streets that are not covered by the BRT corridors. And there will be commercial area around the BRT stations, which is here. with end-of-trip facilities for promoting active transportation. And the next type of neighborhood will be along the coastline, and our goal is to develop these areas into more comprehensive neighborhoods without disrupting their current use. And so we decided that these neighborhoods will be mainly active transportation dominated. So now I'll pass it to Sean to talk about the rest of the design infrastructure.
Thank you, Natalie. So as the population is projected to grow at such a rapid rate, we decided to look into using the largest body of water available to Dar and obtain our water supply from the ocean by building 2 desalination plants. We took the design from the largest desalination plant in the world, the Ras Al Khair hybrid plant in Saudi Arabia, placed it on the outskirts of Dar. After factoring in gray water recycling from our building design, the calculated demand per day is around 2.5 million cubic meters. And each desalination plant is estimated to produce just over 1 million cubic meters per day. So we proposed 2 of these plants with the remaining demand supplied by Dar's current water distribution system. This desalination plant also acts as a power plant using a combined cycle gas turbine technology, and its capacity will be discussed in the energy section. For our wastewater treatment design, we took pages from one of the world's largest treatment plants in Hong Kong, Stonecutters Island Sewage Treatment Works. The estimated capacity is 2.8 million cubic meters per day. 2 of these plants are proposed to be constructed in Dar, which will then discharge the treated water into the ocean. So, as seen in the 2016 urban metabolism diagram, landfills and solid waste account for 32% of Dar's CO2 emissions, and solid waste generated in 2050 is estimated to grow to 5.9 megatons. The strategy that we're putting in place involves turning 100% of the waste in Dar into energy based on 3 different technologies. Biogas power generation from kitchen waste, based on a plant in Tokyo, pyrolysis and gasification of waste plastics, construction materials, and medical waste, based on a different plant in Tokyo, and a reverse acting grate with horizontal boiler system for all remaining waste based on a plant in Amsterdam. The resulting waste treatment will be carbon neutral, and the energy generated is estimated to be around 6,500 terajoules per year, which then brings us to energy. So this pie chart here illustrates the breakdown in energy source for usage in the city of Dar. As mentioned above, 2 new kinds of electricity sources we are introducing are waste-to-energy and combined cycle power plants. So combined cycle power plants have an advantage over conventional single cycle power plants in the way that they recover the heat, producing up to 50% more electricity than their conventional counterparts using the same amount of fuel, and will accommodate about 56% of the city's energy demand. And now the changes in infrastructure brings us to our greenhouse gas emissions. Although we have kept sustainability and carbon footprint reduction in mind while we were designing, we put a heavier emphasis on providing these services to the large population growth in Dar due to their lack of adequate infrastructure currently. Again, the low per capita emissions in 2016 were attributed to lack of access to resources, but through the implementation of our design, we were successful in meeting the demand while still decreasing the per capita emissions by 2050. From 629 kilograms CO2 equivalent to 590 in 2050. And here's the breakdown of emissions by sector. Buildings will be the largest greenhouse gas contributor in 2050. And although transportation still accounts for a large amount of the total, through implementation of our transport design, we estimated a per capita savings of 112 kilograms CO2 per capita, making transportation design our 2nd most effective sector in terms of reducing emissions behind solid waste, which achieved a reduction of 201 kilograms CO2 per capita. I will now pass this off to Natalie, who will be concluding our presentation with the 2050 urban metabolism diagram, as well as the UN Sustainable Development Goal 11.
Thanks, Sean. So here is the updated urban metabolism diagram for Dar in 2050. As you can see, the most significant reduction in emissions is from landfills, with reducing emissions by 201 kilogram CO2 equivalent per capita. And this is because, again, we adopted the technologies that convert waste to energy without a carbon footprint. Another significant reduction is the transportation sector with the implementation of public transportation system as well as the active transportation network, which decreased the emissions from 308 kilogram CO2 equivalent to 196 kilogram per capita. So another thing that worth mentioning is that water supply over here, it is actually now adequate for all the population, to accommodate all the population growth in Dar, which is 16 million people, and satisfy their demand of 157 liters per capita in 2050. So in relating our design to the Sustainable Development Goal 11, which is to make cities inclusive, safe, resilient, and sustainable, the targets cover elements such as housing, human settlements, transportation, and so on. And I want to briefly talk about it, how it is directly in line with the vision that we created for DART in 2050, and how they are very critical for our design to make DART into a sustainable city. So first is human settlements. So currently there are over 70% of the DART population that are living in informal settlements, and characterized by the lack of reliable sanitation services, supply of clean water, reliable electricity, and other basic services. This means only 1.4 million population out of the 4.7 million people are currently having acceptable living conditions. So the second thing is about waste. It is estimated that only 40% of the waste generation in DAR have a formal or informal way of disposal. The remaining waste, which is 60% of it, are actually be dumped by like roadside or drainage canals, which cause a lot of problems such as health consequences because of methane generations and flooding events and so on. And furthermore, approximately only 30% of the population in Salaam currently have access to clean water supply, which makes it a very critical issue to be addressed through our design. Because clean water supply is just a basic human need for survival, sanitation, and health purposes. And lastly, to transportation. Current transportation in Salaam is extremely unsustainable, and there's no adequate road infrastructure or affordable transportation options. And vehicles are often aged between 10 to 15 years old, which cause a lot of pollution problems due to the high exhaust gas emissions. So making it very important for us to address this problem and improve the transportation services in DAR. So therefore, this Goal 11 actually have a lot of targets that have a direct relation to our design city, and it's critical for developing DAR into a sustainable city. So in conclusion, our proposed infrastructure designs align with our sustainable city vision for 2050. And the recommended infrastructure that we just mentioned earlier will provide these necessities to accommodate the high population growth of 16 million people in 2050, including access to adequate water supply, robust public transportation and active transportation system, waste collection and management system, electricity and energy efficient buildings, all while achieving a reduction in per capita GHG emissions. So this is the end of our presentation for Salaam. Thank you for listening, and we're welcome for any questions.